So this video is on elimination. And the aims of this video are to be able to draw the mechanism for an elimination reaction to form an alkene, and to know the conditions for which the hydroxide ion, which is needed for an elimination reaction, will act as a nucleophile, which happens in nucleophilic substitution, which you can watch a video of if you like, and as a base, which happens in elimination. Now we saw in the previous slide the hydroxide ion reacting with the following molecule in an elimination reaction. But the hydroxide ion also can act as a nucleophile in nucleophilic substitution. So depending on the conditions, these two reactions will occur. And we've got to think about these two conditions before we decide which reaction will occur. So the first one that we've seen in elimination is where you have a hydroxide ion that is dissolved in ethanol, and we say that it's ethanolic if it's dissolved in ethanol, and it is also warm in this case. And if those two conditions are met, then elimination will occur. In elimination, the hydroxide ion is acting as a base because it is grabbing a hydrogen ion essentially from the haloalkane. If, however, you have a hydroxide ion that is dissolved in water and so is therefore aqueous and is also relatively cold, then instead nucleophilic substitution will occur, which you can see in a different video. And this time the hydroxide ion is acting as a nucleophile. So if you ask for what the role of hydroxide ion was, in nucleophilic substitution it's a nucleophile, and in elimination it's a base. So let's have a look at a past paper question. Here you've got ethanolic KOH, so an ethanolic hydroxide, reacting with a haloalkane, and you can see actually that it's eliminating, but you could tell that from the fact that it's ethanolic hydroxide rather than aqueous hydroxide, so that would be an elimination reaction. So it says name and outline a mechanism for conversion of 2-bromopentane into pent-2-ene as shown below. Often mechanism questions will have you naming the mechanism as well. So in this case the mechanism is elimination, and all you have to do is just write it somewhere in the answer. You don't have to write a sentence, just write the word, and then it wants the mechanism. So the first step is to draw out this compound with all the bonds showing. You don't want to leave it in a structural formula like that. So you've got C, 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 C. There are 5 of them, 1, 2, 3, 4, 5. And then fill in the bonds, the bromine being on the second carbon along, so this one. Now in an exam you'll have a lot more space than I've left myself on this slide, and so it's wise to use all that space when you're doing mechanisms so that your arrows are directed at exactly the point you want them to be. If you draw your diagrams big, that means that you'll have a lot more space to draw your arrows. So in elimination, remember I said that the OH- ion, which I'll draw in now, the lone pair on the oxygen will attack the hydrogen on the carbon next to the carbon with the halogen on. So it's either going to be this hydrogen here or one of these hydrogens here. Now, as you can see from the product, the double bond occurs here between the second and third carbon along. And so it is this hydrogen that must be attacked. Even though one of these 3 could be attacked, you need to look at the question and make sure you follow the product that's been formed. If no product was given, then it wouldn't matter which side, but because the product is given, you need to make sure you attack the right hydrogen. So we're going to attack this hydrogen here. So the arrow is going to go from the lone pair to the hydrogen. We're then going to draw an arrow from the hydrogen-carbon bond to the bond between the 2 carbons to show this double bond being formed. And then this bromine leaves, so you're going to draw an arrow from the carbon-bromine bond to the bromine. And in fact, that will get you all the marks because it shows you what's made. But if you do want to draw what is made, then it's the product, so C, 5 C's with a double bond in the middle of those two. Make sure you draw it correctly. If you draw the wrong product, then you will lose marks. So it's safer to leave it all together if the product is already given to you in the question. If the product is not given to you in the question, then you do need to draw it. You'll also make a bromide ion, and you'll also make water. Notice I've left out the potassium from this original thing. Now remember, the potassium is a spectator ion. Do not draw it in the mechanism. You must only draw the OH- ion. It then says, draw the structure of the other structurally isomeric alkene produced when 2-bromopentane reacts with ethanolic KOH. So that's this reacting with this, and a different thing could be formed. Now remember, when we started the mechanism, I told you that either these hydrogens could be attacked by the OH-, or one of these three could be. And if one of these three was, then the double bond would end up here rather than here. And so your other alkene that could be produced would be your 5 carbons in a row, but with a double bond between the last 2 carbons rather than here, which is where it is here. And so you'll get 2 H's on there, 1 on there, and then fill in the rest. Remember, carbon should only be making 4 bonds, so make sure you check that before you move on, just to make sure you put the right number of hydrogens around each carbon. I hope that helps. Please email me if you have any other questions.